Okay, I've got the Quanta charger on the bench today, and as I've stated before, there are just absolutely endless configurations to this machine. This is a new one. This here, with all the wires, they're all labeled. This is coil set A. It's A on one side, 1 on the other, and then it goes B, C, D, E, and F. On the other side, it's 1, 2, 3 through 6. And each one is a coil pair, and that pair corresponds to 6 individual bridge rectifiers here. So with this kind of a wiring and labeling, you know exactly what coil is doing what at any given point in time. It's really great. You're able to track everything. But the nicest thing about it is they're all independent circuits with this setup here. And so that you can choose to disable some, you can have 2 opposing ones, you can have 3 triangulated, you can have all 6. Now this particular setup here, I've got the rotor with the 6 positions, and what happens is this is a new setup here. It's a commutator. It's mechanical. Now of course I could use a Hall effect sensor or you know several other different options to trigger this. But it's just a mechanical switch, and it's very, very light, like a hair trigger. There are 6 positions on the rotor here, and it just bumps it for a tiny fractional second. And what it does is it triggers the power from this little rechargeable nickel metal hydride battery, which is charged by this coil inside, actually sitting on the outside of this internal coil here. So when this coil is activated, you get some mutual inductance, plus you get a magnetic field, plus there's a small steel inner ring just on the inside of the green coil inside here. The wire coming down for the positive goes through a diode, so you get nothing but positive. On the negative side, it's an alternating current. So it's very interesting. I've been using this same battery in my prototype for about 7 years, and it has yet to drop below full charge in 7 years' time. So it's lasted a long time, and it's always topped off at full charge because of this configuration of wiring. So it's very, very interesting. And so this runs at about 600 RPM. I'll start it in just a second here. And so you're actually getting 60 pulses per second on this. So what we're going to do with this configuration, this is actually a motor generator, which is very similar to the rotoverter here, in which case it has a lot of torque, and it produces extra energy. And this particular setup produces both back EMF through these output wires here, and you get a boost of inductance at the same time. So you're getting the high voltage spikes of the back EMF through this, plus you're getting some amperage as a kicker, so that doesn't hurt. And so it charges batteries even better. It's a very cool system. It runs on very low milliamps, and I'm going to show you that too. This machine will actually reach maximum torque on the very first pulse. How can that be? Because we've got 6 coil pair sets in here. So in other words, there's 12 coils. The rotor has big 3/4 inch thick N52 magnets, and of course there's a north pole and a south pole on the magnets. So these coils are set up to be north when they're pulsed. There's north on one side, south on the other side. So every time that magnet hits top dead center, that thing pulses a double pulse, a double repulsion. No, I'm sorry, not a double pulse, but a double repulsion. North on north, south on south, and it shoots that magnet out like a bullet, times 6. Every one of these are activated simultaneously, and so the torque, you can hold the shaft on the other side where there's more shaft, and it'll just rip it right out of your hands. It's got a lot of torque. It's pretty amazing. So this thing can run stuff, and you can harvest the back EMF and charge a bank of batteries. Very simple to do. So this is a fantastic configuration, and like I said, it takes to hit maximum speed takes about 2 seconds, maybe 2.5 seconds, and it's up to top speed, which in this particular configuration is about 600 RPM at 24 volts. I like 24 volts because it gives you a little higher RPM, and it still gives you, a nice amount of speed to work with to run something else that you can gear or whatever you want to do. Okay, I've just connected the input wires here. This is for the input, and again, that's for your output, for your electrical anyway. And you have a tremendous, considerable thrust vector on this thing too. So you have that because of that bipolar pulsing action. It's really incredible. We're going to start it now, and watch how fast this just totally spins up. And all I have to do is practically breathe on this thing, and it's just up. There it is. See, about 2 seconds, it's at top speed. Listen to it. Super quiet, and yet you have all, it's kind of like the rotoverter. It's real quiet, but it has a lot of torque, a lot of power, and it provides an electrical output to boot. What can be better? If you already own one of these kits, if you've built this kit, this new configuration will be shown on or will provide it to you on our website. And also with the switching set up here, again, you could use a Hall effect switch if you want, but I try to keep things as simple as possible. The most sophisticated electronics on this whole machine, regardless of how you're using it, is just this solid state relay and 6 bridge rectifiers. Big deal. So, of course there's field effect transistors inside this inside the solid state relay. This is the switch side activated by the charged up battery here through the switching here. So it just gets a 9-volt pulse. It can handle up to 32 volts to operate the switch. And then the contacts here are for the load that's coming in, and they operate on the negative so that it can go, the back EMF can go through the bridge rectifiers and come out as that positive spike, and out these wires, engaging all 12 coils simultaneously while you're doing that. So pretty incredible machine. Listen to that quiet operation. It's a beautiful thing. So there's, like I said, again, there's so many different configurations. Now imagine this. You won't have to imagine it because you'll soon see this machine hooked up to the rotoverter, and I'll probably power the rotoverter up and pull power off of it to charge batteries, plus it will be running this while this is also being pulsed, reducing the drag on the rotoverter, reducing the amount of input needed to run the rotoverter, and yet boosting the inductance on this and still getting your back EMF. So that hasn't been done before, at least not in a configuration like this, and this whole thing is pretty new. You're seeing something real unusual here for the first time. There's no cores on these. There's all air core. You don't want that because it's just going to slow down your rotor. It's absolutely not needed. In fact, all these bolts are plastic. Everything. The only extra metal I have is that little thin ring of steel inside that green coil there, just to enhance that magnetic field, to give enough power to do its thing, to keep that topped off at all times. There it is. Again, check our website if you own one and you want the circuit to do this, to rewire it in that configuration. It's real simple. I'll show you how. There's pictures, there'll be pictures in there of how to join those wires together to keep them all grouped together nice and tight like that. It's quite easy to do. One final point here. Again, I said that the input power is 24 volts here, and I want to show you, I've got it connected to the ammeter, if I can get that reflection off of it, and if you can see that, this camera is not very good for close-ups, but it's pulling about 250 milliamps to maybe 300 milliamps at 24 volts to give you the incredible amount of torque and extra charging capability. Here's the other side. There's the output shaft side. This is the side that will connect to the rotoverter. I'd also like to mention that I believe that because of the way this system is wired up, it may be feeding a little power back into the batteries, because on its own, just like this, and extracting some back EMF and with the induction, and if you don't want the induction, you can just connect to the positive input line or to the positive of your drive battery, and connect that to the negative of your charging batteries if you've got a single battery or a bank of batteries, and then just take this positive lead and go directly to the positive connection of your charging bank. But it may be feeding some power back into that run battery, even though it's hardly drawing anything at 250 to 300 milliamps here at 24 volts in this particular power input, because it'll run for hours, and I suppose it's possibly because that input is so low, but it'll run for hours and maybe drop 1/100th of a volt of the batteries that are powering it. So pretty incredible, just to even at that, to get the kind of torque, and even under full load, a load so heavy that it just about stops that shaft from rotating, and it takes a lot to do that. It still ends up only pulling about 2 amps maximum on the ammeter at 24 volts. So you're talking about 48 watts to do a lot of work and get power output. So I'm quite certain that the COP is very high on this configuration. Thanks a lot.